The very first thing is they ask us to find the x values for which this graph will be increasing. Now remember, what did we have? We had the graph coming down, going up, and coming down. We had here that the x value was -1, and we had there that the x value at this point, not g of x, but the x value at that point was 2. Okay, so we knew that between -1 and 1, the function is increasing. And that's what they're asking us for 2 marks. They are saying, where's this function increasing? Now, folks, please, I'm going to make a note here for you in your sketchboard. Okay? In the sketchboard, for something to increase, it means the following. As x is becoming bigger, y is becoming bigger. That is just in plain English. In derivative language, a big tip where you can calculate this with, the increasing function is where its derivative, now in this case we're having g, so it's where g's derivative will be positive. It will be decreasing where the derivative of g of x is negative. And then also it will be stationary where that derivative is 0. So it's a stationary point where the derivative is equal to 0. Okay, so we've got that now. Now, to write down the answer where it's increasing, that g will be of x will be increasing on the interval where x is bigger than -1 and smaller than 2. That is where it's increasing for 2 marks. Please remember, folks, you do not include the equal to, because where it's equal to 0, look at your tips, where it's equal to 0, it's stationary. So it's either strictly bigger or strictly smaller, depending on what it is that you're looking for. Okay, now we will be looking at question 8.2. Now, folks, remember 8.2 is asking us for the point of inflection. Now, if we do not have the equation of the cubic curve, which in this case we don't, then we have to work with the turning points, which we do have. So we have this x value and that x value. And I'm going to write the tip here for you that you are going to focus on the symmetry between the SPs. SPs stand for stationary points. So you want to land up directly in the middle of those 2 stationary points. So all that you have to do is you have to say, okay, to find the midpoint between the 2 points, I add those x values and I halve them. I can only find the x values because I don't know what the y values are. So if I add those 2, this is then going to become 2 minus 1, which means x is equal to a half. And that is where our point of inflection lies, directly in between the 2 turning points by symmetry. Okay, then they continue. They're asking us now, where's this function concave up or concave down in this case actually? They're saying, for which values of x is the function concave down? Now let's quickly just draw that graph again that we had with all the information. We had that this is what's happening. At 2, x equal to 2, there was a stationary point at x equal to minus 1, and point of inflection here at x equal to a half. So let's do this, put this on the sketchboard, or rather put it on the tips. because this is very important. Concave downwards means the gradient is becoming smaller and smaller and smaller. Now, how do I remember this? Well, I look at this n. The n shows me that that is the shape of the n. So where that is the shape on the graph will be where the function is concave down. Obviously, the other one will be concave upwards. So the n for the down, the concave and the down, brings me to that shape. If I have a concave upwards, okay, all I need to remember is this u. A u looks like that. So that means the gradient of the curve is increasing. Okay, so asking us is where is it concave down. So the graph will be concave down where it takes on this shape in the tips. Or if you want to write it down in your sketchboard, it is where the second derivative is bigger than naught. Okay, and here the second derivative is less than 0 over here. Okay, so let's see. Concave downwards would mean here's the point where the gradient, the nature of the gradient is changing. So it will be to the right of that point. So G is concave down where x is bigger than 1 over 2. Okay, and it carries on forever. It carries on up to infinity. There the graph is concave down.